Okay, so if we want to solve these sorts of radical equations using technology, it's pretty darn straightforward to do so. You just put it into Wolfram and see what comes out. So like the first one, for example, wants x to the power of 1/3 minus 5 equals negative 2x plus 1. And if we plug that into any sort of graphing software like this one, we're going to get a graph. And although this graph is a little bit zoomed in, we see the general idea here. I think probably if we tell it to use the real valued root, it's going to work a little better for us. Can you give us a graph? There we go. Oh, no, same graph. Okay. So we can zoom this graph in a little bit, and we can click the enlarge button to see that. But the point is, we've got this kind of cubic shape to our graph intersecting with a line. And we actually are told a very, very close approximation to the solution here at 2.3365. So what I want you to do is sketch this graph, and you can sketch a zoomed in version if you can make that happen, and then give me the approximate solution at 2.3365. You do the exact same thing for the next question down. So if we want to look at x minus 5 to the power of 1/4 and have that equal to 1/2 times x minus 3, we can plug that in. And again, it will give us a graph. That's a much nicer looking graph now. That's closer to what we saw in class. And it should also give us an approximate solution. Sure enough, x is approximately 8.7909. So you'd copy that graph and you'd find that approximate value. So all you really need to do, besides drawing those two, is do the third one. Negative x to the power of 1/2 is equal to negative 4x plus 8. And show me that in class tomorrow. And hopefully we're good to go from there. Thanks for tuning in.